Thank you. We draw the line. We establish which side of the line is the appropriate side to shade, and then we shade that side. That's all we're doing here. We're just going to do it twice, or maybe 3 or 4 times on the same coordinate plane. Okay, so you'll see the instructions are here, but it's kind of straightforward. It just says select one of the inequalities, place the symbol with an equal sign, draw the line. If it's less than or greater than, it's dotted. If it's less than or equal to or greater than equal to, it's solid. And then we use the test point. I said the best test point to use, we said, was 0, 0. Whoops, I want that. 0, 0. If 0, 0 works, that's the side you want to shade. If 0, 0 doesn't work, you want to shade the other side. Okay, that's as hard as it really gets. And then we're just going to do that. The only new real thing is we're going to repeat that 1, 2, 3, maybe 4 times. Okay, and then we're done. And I'll show you some examples on my math, how simple it is. If we did this in class, it actually would be more complicated. But since it's on My Up in Math, the graphing tends to be a little bit easier because it does a lot of the stuff for you. Okay, and then the intersection of the 2 shaded regions is the solution set to the system of inequalities. This is called the solution set, or it might use this on My Up in Math. This is called the feasible region. They're synonymous. Feasible region and solution set mean the exact same thing. Okay, so we're just going to dive right into it because it's not that difficult. We'll probably get out early today, but we'll see. So the first one says graph the system and indicate the solution set. So we're going to do this one by hand. So they're both written in y equals mx plus b form. So I'm just going to rewrite the first one. I'm going to do the first one in blue and the second one in red, just so you can see where my work is. So the first one, I have y. I'm going to ignore the inequality sign. I'm just going to do y equals 2x minus 2 for right now. Since it's in slope-intercept form, I know my y-intercept is 0, -2. And my slope is 2 or 2/1, however you want to write it. So I'm going to start at my y-intercept, 0, -2, boom, down 2. I'm going to use my slope to find a second point. So from there, I'm going to go up 2 over 1. So I'm going to go up 2, boom, boom, back at the origin, over 1. I'm right there. So now when I connect these points, I have to either use a solid or dotted line. But since it's less than or equal to, that means the line's going to be solid. So I can connect these 2 points like so. Extend that line a little bit. Like that. And then I have to figure out, is the 0, 0 side the side I want, or is the other side the side I want? So we're going to test 0, 0. If 0, 0 works, shade that side. If 0, 0 doesn't work, shade the other side. So if I plug 0, 0 into this equation, I plug in 0 for y and 0 for x, I get 0 is less than or equal to 2 times 0 minus 2. I get 0 is less than or equal to, this is just 0, so I get -2. 0 is not less than -2, all right? 0 is larger than -2. So in this case, this is false. So with respect to 0, 0, this point doesn't work. So when it comes to the blue line, I'm going to shade below it. But I'm not going to shade right yet. I'm going to just put these little arrows first, because I don't want to get too, when you're doing them by hand, if you scribble all over the one side of the graph, it can be hard to do your work for the next line. Computer is much easier, but for this kind of work, we're just going to put the arrows and we'll shade in at the end. Okay. Now the second equation is y equals -x plus 3. So my y-intercept here is 0, comma, 3. My slope is -1 or -1/1, depending on how you want to write it. So to graph this, I'm going to start at my y-intercept 0, 3, 1, 2, 3. And from there, I'm going to go down 1 over 1, because my rise is -1, down 1 over 1. So I go down 1 over 1, I'm right here. So now I have to figure out, okay, is it dotted or shaded? Well, since it's just greater than, my line's going to be dotted. So I can select that like so. Extend that. Dotted, thank you. Yes, I wasn't looking up. Thank you, Yadiomi, yes. So I have to figure out, is it the 0, 0 point work or not work? So I'm going to plug 0, 0 into this guy. So I test 0, 0. I get y, or I'm sorry, 0 is greater than -0 plus 3. -0 is just 0. There's no such thing as -0. So I have 0 is greater than 3. 0 is not greater than 3. That's, again, a false statement. That's false. So we don't, just with respect to the red line, we don't shade the 0, 0 side. We're going to shade the other side. So I'm going to put arrows above it. So I'm almost done. I have just one small step left. I just have to figure out which section of the graph satisfies both of those inequalities. So it's going to be everything to the right of the blue graph and everything above the red. So where those two things overlap is just this part right here. So you can have fun coloring that in if you'd like. So any XY point that I pick that falls in that purple region will satisfy both of the inequalities in my system, okay? That's it, that's what you have to do. Any questions on that one?
No, pretty good at that.
Okay. All right, cool, excellent. Let us try another one. So I'm going to do this first one in green. Second one in orange. How about that? So the green graph, these are both now written in standard form. So I'm going to graph them using intercepts. So for the green graph, I'll start with the y-intercept. So I'll let x be 0. So I'm going to plug in 0 for x. And I get 0 plus 2y. I'm going to use an equal sign now, right? When you graph it, you just use an equal sign. Equals 4. So this goes away. I'm left with 2y equals 4, or y equals 2. So I have the y-intercept of 0, 2. Now I'll do the x-intercept. I'm going to let y be 0. And I'll get x plus 2 times 0 equals 4. This goes away. I just get x equals 4. Pretty straightforward. So I have those 2 points, 0, 2 and 4, 0. Connect those. Y-intercept 0, 2 is right there. 4, 0 is right 1, 2, 3, 4 right there. I will connect these with a solid line because it is a greater than or equal to. Oh, that's dotted. Let me fix that. Valid. Oh, Don't want to move the dot, I want to move the line. Okay. And just like before, I want to see if 0, 0 works. So I'm going to test, so fit this in right here. Test 0, 0. Plug 0 in for both numbers. 0 plus 2 times 0 is greater than or equal to 4. I get 0 is greater than or equal to 4. 0 is not greater than or equal to 4. This is false. So I'm not going to shade the 0, 0 side. I'm going to shade the other side. Start by using just the arrows. We're going to shade the very, very end. Eventually, we'll find one where 0 does work, but it seems like a lot of these doesn't work. All right, the second one. Start with the y-intercept. Let x be 0. So I have 3 times 0 minus y equals -6. Be careful here. This goes away. I'm left with -y equals -6, or y equals 6. So I get the y-intercept of 0, 6. Now let's do the x-intercept. Let y be 0. So I'll plug in, I lost my equation. Plug in 0 for y, I get 3x minus 0 equals -6. So I get 3x equals -6. Divide by 3, I get x equals -2. Okay. So I get the intercept -2, 0. So I'll connect those 2 points. 0, 6. 1, 2, 3, 4, 5, 6. -2, 0. Over to the left, 2. This is again a greater than or equal to, so I'll use a solid line. You don't have to use the arrows, but I just did them. So again, we got to check to see if 0, 0 works in that equation. So I'll plug in 0, 0 for both of them. Testing 0, 0. I get 3 times 0 minus 0 is greater than or equal to -6. You only care about the inequality when you're testing. Other than that, just treat it as an equal sign. So these two things become 0 is greater than or equal to -6. Ah, finally, we got one that's true. 0 is greater than or equal to -6. So in this case, the case of the orange, the point 0, 0 does work. So just looking at the orange, I'm going to shade towards the 0, 0 side. Like that. And then the last step, I guess green and orange make what, brown? An ugly color, greenish brown, greenish baby poop color. Okay.
Orange.
Orange and green make orange, you said? They make like a muggy, like a baby poop color. Yeah. Carrots and peas. So it's everything to the right of the orange line, everything above the green. So it's going to be this section here. Okay. So any coordinate in this region is going to satisfy both equations. Okay. Any questions on that? Baby poop color. Allison should use that color, or Alyssa should use that color next painting. And she's a painter. Baby poop green. It's a beautiful color. Yeah. Any questions on this one? Okay. I'm not sure if there's any word problems specifically on systems. Let me look real quick. We'll just pull up your problem set. Let me just run through it. This is the problem set. Yeah, let me make this a little smaller. Let's see. There's not many word problems in this chapter except for the very last section, which we'll talk about on Monday and Wednesday. Yeah, that's the last section, last section. Yeah, so there's no word problems on this stuff. So I won't even bother. Well, maybe we'll do it. It'll help. We'll just do it. It's fine. It won't hurt anybody. So thank you, Alyssa. Yeah, I want to see it when the final product when it's done. Not the word problems, no word problems today. We don't have to do this one. We can skip this one and just practice some. We'll practice some math stuff. We'll skip that one. There's more baby poop green. Okay, so I'm going to jump to math. So if you just want to follow along on a piece of paper or something. No, you're right. We don't have to do them because they're not on the math. We'll do plenty of word problems Monday and Wednesday of next week. So I have no problem skipping that one. But I did want to go over a couple of these just to show you how to graph them and what specifically they're asking for. All right. So I'm going to copy this guy over. I'm going to do 20 and 21. I don't actually like that word problem anyway, so really silly one. And then we'll do this one. And if we get, you can do that one too if we have time. All right, so because these can be confusing how to graph them, but do it together. Do blue. We'll do the first one in blue. And the second one in, well, we'll do something you can see, red. You actually have to do less work because it kind of figures out the overlap on its own. So this first one, they're both in y-intercept form. So this first one, we're just going to say, okay, the y-intercept is 0, -2. And my slope is 1/2. So I'm going to start at -2. From there, I'm going to go up 1/2. So I'll go there. I will connect them with a dotted line. Extend that. And then I'm going to test 0, 0. I get 0 is greater than 1/2 times 0 minus 2. This goes away. I'm left with 0 is greater than -2. That's true. 0 is greater than -2. So I'm going to shade above that line. I'm going to put little tick marks. So I'm going to try and show you how to do this on the math. So my y-intercept is -2. My slope is 1/2. I'm using a dotted line and I'm shading above it. So this is number 20. So before you do anything, you want to pick what kind of line you want. So we said it was a dotted line. So I have to select that first. Then I'm going to start my y-intercept, which is 0, -2. Make sure you get as close to that point as you can because it marks it wrong if you're off by a little bit. So there I am. And now it's asking me for the second point. So you're going to have to figure out from there, I have to go up 1/2. And there's my boundary line. And we said 0, 0 worked. So you can either pick any point on this side or any point on this side. So I'll just click 0, 0. That's the best thing to do. Just click 0, 0. It does work. All right. And now you're automatically set up to graph the next line. So each line only requires 3 points. If you try to add anything else, it's going to mess you up. So let's go back to our work. I'll do this, well, it's kind of reversed. I did this and I flipped these, didn't I? That should be red. So that'll be red. And the next one will be in blue. So this guy here our y-intercept is 0, positive 2. Our slope is negative 1 over 1. Negative 1. And we will start by graphing that 0, 2. Down 1 over 1, so I'm there. Excuse me. And I'm going to connect those with a dotted line again. Thank you. It's very nice to see this. Say bless you in the comments. I'm going to connect them with a dotted line because it's just less than a blue dotted line. If we were in person and I sneezed, I'd feel very guilty this day and age, but I'm glad I'm away from you guys. I don't feel bad about sneezing in front of you. And now we're going to test 0, 0. So I have 0 for y is less than negative 0 plus 2. I get 0 is less than 2. That is also a true statement. So now I know I have to go from 0, 2, down 1 over 1, and I'm going towards 0, 0. So I'm going to go back to that. So I'm going to make sure I'm in my dotted line. It's dotted line again. I'm going from positive 2, like that, down 1 over 1, and I'm going towards 0, 0 again. So it won't, I don't think it'll let you click that point again. It looks like it won't. So just pick any other point in this side. Doesn't matter where you put it, just as long as it's on the 0, 0 side. Okay. And that's all they're looking for. You're done there. There's nothing else you have to do. You don't have to like draw the overlap or color in the overlap. They just want you to draw the inequalities. So if you look at the answer here, this is the same thing they have. Okay. That's all they want you to do. Just make sure you only use 3 points for each line. Once you've done the 3 points for the first line, you got to move on to the next line. All right. Same thing here. Question 21. We'll do this all on the scan or the smartboard, and then we'll transfer it over. Yeah, let's do that one. Then we'll probably split early, unless there's questions. All right. So I'll do the first one in a, let's see here, nice magenta like that. Or maybe let's look at pink. There you go. That's nice. Yeah, that's a nice color. Okay. So this first one, they're both in standard form. So I'm going to graph using intercepts. I'll put it over here. So I'm going to do 0, comma, for the y-intercept. So I get 17 times 0 plus 10 times y equals 170. So this goes away. You kind of notice that when you do the intercepts, you can basically, it's kind of hard to do, but you can just like just cover this thing up and solve that equation, and then do the flip. Cover the next one up, solve the first equation. So I have 10y equals 170, or y equals 170 divided by 10, 17. So this is going to be 0, 17. Now we're going to do the y-intercept, or the x-intercept. Y be 0. So I get 17x plus 10 times 0 equals 170. This goes away. I'm left with 17x equals 170, or x equals 10. Very nice, very nice. Okay. So I'm just going to connect those. I have to test 0, 0. I get 17 times 0 is 0, plus 10 times 0 is 0. Is less than or equal to 170? Yeah, that's true. And this is going to be a solid line because it is less than or equal to. So we're going from 0, 17 to 10, 0 with a solid line. I'm going to have to zoom out a little bit here. So it's expecting me to just do, doesn't know which line you're doing first, but just start with the top. But we're going from 0, 17. Right? Oh, make sure I'm solid line. 0, 17, right there. Down to 10, 0. We're going to shade towards the origin. Doesn't matter where you put it. Right there is fine. That's my first guy. All right, next one we'll do in a gray. This will be in gray. All right, same process. Plug in 0 for x. This just covers up. I get 14y equals 196. Divide both sides by 14, you get y equals 196. 14 squared is 196. I'm sorry, you get y equals 14. My bad, brain fart. 14. 196 divided by 14 is 14. And notice they have the same coefficient, so this is really easy. So if I want to do the x-intercept, let y be 0, I get the same thing. Cross this out, you get 14x is 196. So you get x equals 14 as well. Those are the nice ones. So I'm going from 0, 14 to 14, 0. And then I'm going to test 0, 0. And I get 0 plus 0 is less than or equal to 196. I get 0 is less than, yeah, that's true. So I'm going from 0, 14 to 14, 0. Here's 0, 14 to 14, 0. Going towards the origin. Pick any point towards the origin. Now, if you hit submit on this question, it's going to mark it wrong because we're missing 2 more inequalities. We're missing this guy and this guy. All right, so I'll do the next one in blue. So I'm going to graph x is greater than or equal to 0. So I told you when you're graphing these, treat the inequality as an equal sign. So basically just graph x equals 0. Well, we know that if you have x equals something, that's going to be a vertical line. Vertical line at 0. So that's basically be the y-axis. X is equal to 0 is the y-axis. So then this is a weird part because I'm going to say, all right, well, here's the coordinate plane, whatever. If this is my boundary line, I can't test 0, 0. Whoops, can't test 0, 0 because 0, 0 is on that line. Okay, you can't test 0, 0 if it actually falls on the line. So I have to pick any other number. So if I go, let's just say I pick, I'm going to test the point 5, 5. I can plug 5, 5 in. You don't really have to because it kind of makes sense, but if I plug in 5, 5 for x, there's nowhere to put a y. So I'm going to say, is 5 for x greater than or equal to 0? Yes, that's true. So 5, 5 works. So here I'm basically just going to graph the y-axis and shade towards the positive side, shade in the positive direction. So I'm just going to pick any one point on the y-axis. Let's say 0, 2. Any other point on the y-axis, doesn't matter, 0, 9. Then I'll shade towards the point 5, 5, which is right there. Okay. And kind of following that logic, y equals 0 is the x-axis. So I'm going to pick any 2 points on the x-axis. We'll say 3, 0 and 7, 0. And it wants the values that are greater than y. So you can assume it's going to be shaded up. Pick any point above that line. And it's messy, but that's what they want. They just want you to graph all 4 things on the same coordinate plane, and that's it. If you submit it, hopefully you'll see, I got it correct. Good. That would be embarrassing if I didn't. So that's all they want you to do. It's a lot, but that's it. Same thing for 22. You're just going to graph those one at a time, put them all on here. Oh, actually, this is different. Let's look at this one. Graph the feasible region for the following system of inequalities by drawing a polygon around the region. Okay, let's do this one, then we'll get out of here. This is a good one.
Excuse me, I'll be right back just a moment.
Okay, that's fine. Yep. All right, so I'll do the first one, purple. I'm just going to go through the intercepts rather quickly because we know how to do them. Here we get the points 0, 6 and 42 comma 0. And that's going to be a solid line, and we're going to shade towards 0, 0. Okay. You don't have to worry about that really. Shade towards 0, 0. Second one we'll do in green. I let x be 0, cover that up, and I get 7y equals 42. So when I divide by 7, I get the y equals 6. Okay. Just basically cover that guy up, this whole thing, because x is 0, and then you'll get y equals 6. This one here, same thing, let x be 0, you get y is 40. Let y be 0, and you get 5x equals 40 or x equals 8. Again, we're going to shade towards 0, 0. And then this just means we're above the x and y axis. We know what that means. Don't worry about that right now. So I have to figure out the shape. Basically what they're looking for is for me to just draw this shape here, this is the part that satisfies all of the inequalities, that inner quadrilateral thing. Okay. So I have to figure out where they intersect. So what I'm going to do is I'm going to just draw a rough sketch. All right. I'm going to draw a rough coordinate plane because this is not big enough to fit these two intercepts on here. So it's going to look like this. Doesn't have to be perfect. I just want to look at some rough numbers. And I know this purple line, I told you before, it doesn't matter where you put it, is going from 0, 6. We'll say 6 is here, 0, 6 to 42, comma 0. Just draw it like that and label it. That's all. This is from 0, 6 to 42, comma 0. It should be in purple, but. And the other one, the green one, is going from 0, 40. If this is 0, 6, 0, 40's got to be like up here, right? 0, 40 down to, what did we, oh, darn it, what did we say? 8, 0. So we have 0, 40 to 8, 0. Something like that. This is 0, 40. And 8, 0. Okay, and then everything above the x-axis and to the right of the y-axis. So you'll see that my feasible region is this part right here. Because we're shading towards the origin with the green line, towards the origin with the purple. So this is my feasible region. So that's what they want me to translate right here. They want me to put this shape, just this shape, right here. The problem is I need to figure out, before I can just plot points, I need to figure out what this point is. What's that point? I don't know what that coordinate is. All right. So I need to figure out the intersection of my boundary lines, the intersection of the two lines, which is the same thing as saying solve the system. There's the first line. Here's the second. Solve the system of equations, like we did last class. So remember, I'm going to multiply one of the equations by something to get the matching opposite coefficients in front of one of the variables. So I'll multiply the first equation by -5. So I'll have positive and -5 in front of the x's. So I get -5x minus 35y. Whoops, I'm multiplying the top equation by -5. That's okay, Yadi. I mean, yeah, you can watch the video later. Have a good day. Have a good weekend. -5 times 400 or 42 is -210. Now I can add these together. It's going to work out nicely, I promise. What did -5x, -35y, -210. Now we'll add these together. 5x and negative 5x. That gives me 0. That's what I wanted. 5 plus negative 35 is negative 34y. 40 plus negative 210 is negative 170. So I have to divide both sides by negative 34, and I get y equals positive 5. That's nice. So this intersection is going to be something, comma 5. Well, I need the x value too. So take either equation and plug it back in. So I'm plugging it into the second one. 5x plus y is 5 equals 40. So I have 5x equals 35. I subtracted 5. Dividing by 5, you get x equals 7. So this point here is 7, comma 5. All right. So I'm gonna go from 0, 0, this bottom corner here, to this point here, 0, 6, to this point here, 7, comma 5, to this point here, 8, 0, back to the origin. All right, that's what we're gonna do. 0, 0, we're making the polygon. 0, 0 to 0, comma 6, like that, to 7, comma 5, right like that. And you see the other one was 8, 0, I think. Hope that's right. Can't go back. 8, 0, back to the origin. You see it shades in as soon as I'm back to the origin, and then you're done. That's your polygon. Okay, that's the answer. It's just combining two things we've already done. All right, inequalities and then finding the intersection of the lines. Those are tricky. All right, you'll do the same thing here. This one's a little more straightforward because you can do it on the graph itself. Question?
What happens if it's like in between a line? Like let's say it's between 7 and 8, like literally
It's like a decimal.
Yes.
I don't know if too many of those pop up, but if they do, just try and get it as close as you can. If it marks it wrong, I will go back and fix it. But I think most of them should be whole numbers. Okay, if you get a net decimal, you're not sure what's going on, email me and I'll check it. And if you're right, then just try and eyeball it as best you can. It's not perfect, but okay, Joe, we'll see. Have a good weekend. So this one here, you can kind of, it says graph just the feasible region. Don't graph each inequality, just the final product. So you have to do this on another piece of paper as well. So I can do this one real quick, and this one will be easier because we can see where they're actually crossing. So let me copy this one, and then we'll get out of here. This is the last one we're doing, I promise. Shrink this a little bit. Okay, the first one, I'm just going to run through it quickly to show you how to do it. The x-intercept here, if you let y be 0, is going to be 11, comma 0. The y-intercept for the x be 0 is going to be 0, comma 11. Right, you just make one equal 0, you have 11, the other one's 11. Solid line, we're shading towards 0, 0. So I'm just going to graph that. Blue line from 0, 11. Oops, nope, no. 0, 11. Nope. This is what I want. I go 0, 11 to 11, 0. There's that line. Okay. Next, I'm going to do this guy in red. So this is let x be 0. I get y as 3. If I let y be 0, this goes away. I'm left with negative 3 equals 3 at negative 1. Solid line, we're shading towards 0, 0. So I'm just going to connect those. 0, 3. Oops, that's not a line. 0, 3. 0, 3 to negative 1, 0. That. And now you look, I'm going that way, right? It's weird. I'm going to extend it so it touches my other line. Try to make it as accurate as possible. Like that. And I'm shading towards the origin. So right now it's inside this triangle here. Don't forget these other two guys. This means everything to the right of the y-axis. This means everything above the x-axis. So if we draw those lines, my next boundary is going to be the y-axis, like this, and the x-axis like this. So now if you look at my region, it goes from here to here to here to here. This is 0, 0. This is 0, 3. This is 2, 9. And this is 11, 0. 0, 0, 0, 0, 3, 2, 9, 11, 0. So let's try that. 0, 0, 0, 3, 2, 9, 11, 0. Now, sometimes these have to be like exact. See, that didn't work, right? Let's clear all. 0, 0, 0, 3, right? 0, 3. 2, 9, 11, 0. I don't know why it's not connecting, but so that one, that's gonna be marked wrong because look, that's their answer, but it's being finicky. So when that happens to you, just email me when you're done and say, hey, I marked it wrong. I probably marked my answer wrong, right? No, they marked it green, I guess. It's just pain in the butt. All right. So unlike this one, when it fills it in, this one they don't fill in for you. I don't know why, but that's how it's done. Okay. So you're going to have to do a lot of these on probably a separate piece of paper, just so you have a place to do your work. I would recommend getting some graph paper or something like that. But definitely start looking at some problems in the problem set and letting me know if you have any questions over the weekend or next week. All right. And Monday we'll start the last section. It's kind of taking everything and bringing it together. And then Wednesday we'll do the same. And then Friday again, you'll have off to do your 2 assignments. And then that starts your spring break. I won't see you for a week after that. Okay. Are there any final questions?
Mr. Roach,
Yeah.
you said that we can also
Yeah.
email you about doing it, extending it, was it?
So the 12th is the technical due date, but if you need extra time, you can turn in the 14th or 15th. That's fine too. Okay, but that's technically your spring break, so I didn't want to make it due that day. So it's due the 12th, but if you need more time, just email me and you can have it. Okay.
All right.
All right. If there's no other questions, then you guys have a wonderful weekend, and I'll see you Monday.
One moment.
Thank you.
Yep. Thank you. Take care.
You too.
Yeah. Do you know how to solve this type of problem? Oh, it's a bit too dark. One moment.
Is it on your My Have a Math? Just tell me which problem it is, and I'll pull it up.
Oh, it's on problem, practice problem, system of linear equations, question 7.
Hold on 1 second. Whoops. 1 second. I'm not popping up on my My Up and Math. Hold on. Find student. Oh, Danny Shields. Okay, I got you. Problem, you said, which problem was it? Just tell me the number again. It's systems of linear equations.
Yeah, number 7.
On the practice problems,
Yeah, practice problem.
it says you got them all correct.
Well, yeah, I did it on a fluke by accident,
Oh,
but
okay. All right.
I still like to know how to
I got
do
you.
the actual equation.
All right. Number 7. Let me copy that. This one here.
Yeah.
Okay. So they're not written in standard form or y-intercept form. So I want to change them to those, at least one of those forms first. So remember, standard form is when you have the x and y on the same side and they're equal to something. So I can just start by moving this guy. If I subtract 14 from this side and this side, this first equation becomes negative 2x plus y equals negative 14. That's your first equation. And then I can move this negative 16. I can do plus 16. And I get 4x plus y equals positive 16. Now it's just a matter of solving it using the elimination method. Does that make sense?
Yep.
You want to see it done?
All you did is
Just move these constants to the other side. Subtracted 14 and added 16.
oh, okay, and then after that,
You would just you could multiply this one by positive 2, so you get positive negative 4x, and eliminate them. Do you want to see it done?
yes.
Okay. I'm going to distribute this 2 to every single term. I'm going to write it underneath though. So 2 times negative 2x is negative 4x. 2 times y is 2y. And 2 times negative 14 is negative 28. So I have my matching opposite coefficients here. So when I add these equations together, this is going to cross out, this is going to cross out. So I have y plus 2y is 3y. And I have 16 plus negative 28 is negative 12. So from there, solve for y, divide by 3, I get y equals negative 4. So there's my y. And now I want to take that y and plug it into either equation. The bottom one looks a little nicer and to find out what x is. 4x plus 4 equals 16. I get 4x minus 4 from both sides equals 12. Divide by 4, I get x equals 3. So my solution is 3, 4. But you had 5, negative 4. Why is that? 28, 4x, y, 16. Huh. 4x plus y. Why am I getting something different than you? Negative 2x plus y equals negative 14. Yep. 4x plus y equals positive 16. So I multiply by 2, and I get negative 4x plus 2y equals negative 28. Negative 12. Oh, I know why. Duh. My first answer, y equals 4. 3y equals negative 12 divided by 3. This should be negative 4. Negative 4. My mistake. So that changes this. So this is 4x minus 4 equals 16 when I plug it in. Okay. And I add 4 to both sides. I get 4x equals 20. Or x equals 5. So my solution is 5, -4. Okay. The only new trick was just to make sure they're in standard form by adding this 14 and this 16 to the other side.
So the system of equations, is that just some adding?
It's
That-
the elimination, yeah, elimination or substitution method.
Oh, okay.
Okay. Sound good?
Yeah, and what happens if it's on fractions? Like,
Like-
let's
Which one?
one moment. I saw that I saw that the other day in one moment in your equation. Yeah, that's just it. Like, I know I saw it somewhere, but it's like x out of 4, and then after that plus or minus y over. Damn, I saw it earlier.
I'm looking at the problem set. Hold on.
What the hell is it?
Oh, if you find it, just email it to me. Let me know the number and I'll send you a video, no problem, okay?
Okay.
All right. Until then, just have a great day.
All right. See ya.
See ya.